So this is basically a very basic session about how my journey as a programmer, and I'm basically a programmer by profession, and uh, not a, not really started hacking since the past couple of years, and how it made me change my approach towards programming and how it made me look at stuff in at a completely different light. So that's a bit about my journey, and yeah, you'll find out some stuff. So, like I said, a bit about me. Basically a programmer with around 20 years experience. I'm working at Mini Orange here. And being a cybersecurity enthusiast, my company itself is a cybersecurity company. And I like delving a little about ethical hacking and cybersecurity hygiene. And I have been programming a lot. Since the past 20 years, I had many programmers out there, by the way. Any people who have, oh, pretty much everyone. Any web app developers or hackers. Less hackers, okay. So yeah, and more for JavaScript, Python, PHP, and Java by. I actually started my first programming lab with a logo. Anyone has heard of logo? How about
These two, or
sorry, yeah, I'm third.
Go.
Puff. It's a cute language. So that was the first one that actually started my journey to programming. And since I've done all these languages and work a lot, I'm primarily in Java right now. So the first question why people ask me is, why do you want to hack? The cool, simple, and lazy answer is it looks cool. Like they grew up in a Matrix era. So like it feels cool to hack. And if it literally feel like new and this at times. But that's not all the complete truth. The complete truth is that I love breaking stuff more than I like making stuff. I book a lot more applications than computers. So I love breaking stuff down and then deciding how I can build it back up. So it is the core reason why I love that. So like I said, I love the Matrix as well. So the app dev and hacking section, and this is primarily where I like to explore. I think a lot of sessions also cover the same, but I'll again reiterate the same. So, what did I learn? So, like I said, I've been a programmer for most of my life. So I started hacking a couple of years ago, and the way I started it was I read up a lot about those tools like Burp Suite, Kali Linux, and OS, Zap, and all. And I started experimenting a lot with those tools and scripts. I wrote my own custom scripts as well. And I read up a lot on their documentation and how I can use it to hack. I read up a lot on Reddit as well. So that's a very weird place to be. And I tried all those gamification platforms that are Hack the Box and Try Hack Me Up, those sort of places. OneHub is another place that I try a lot, and it gave me a little more information. It gave me a way so I can practice what I've learned and read about. And yeah, it gave me a very simple hacker mindset. I started to look at stuff in a completely different light. Instead of looking at, like, say, a form on a web application, I just think, what goes on under the hood? Let me have a look at the request and response. What information I'm passing? How can I break this application? What all goes beyond my network? It sort of like gives you a different place that you can explore stuff rather than just passing information and getting some information back from the server. So yeah, it was an interesting place and gave me a little more information about it. So, was I satisfied? Not really. Now, why would you ask? Being a programmer, I wanted to see that, okay, I have a lot of applications that I have personally worked on, my team members have worked on. So, why not try and hack those? Let's see what happens. So, as a cautionary tale, I did attacks a lot of my own applications, and I cannot really use those as part of the session. So what I did was I created a very dummy implementations of those same applications. They're doing essentially the same work. It is just that those are sort of like MO applications. So we use 3 case studies here and as part of 3 applications, and this see what I ended up finding out. So yeah, this Clump is actually that stuff. So the first application is a Node.js based application. It is essentially a wrapper around around a web application, which just exposes a lot of APIs for authentication and data retrieval, and is connected to a backend PostgreSQL database. So what did I do with this application? The first lazy stuff that I did was I just hooked it up to Go app, and I did get a report around it, and I could see that it is a little vulnerable to SQLite. It does not have a very good CSRF implementation and a few other low and informational vulnerabilities. So yeah, but this did not give me a lot of information. It did not give me a way that I could actually exploit that. It's more representation. So I wanted to do a little more investigation. So I just connected the application to Work Suite and started looking at the different APIs. Now, just a reminder that this is more of a gray box approach, because I have been responsible for working on a few of these applications. So I had more liberties, the APIs and how they're built and deployed. So I looked at the different APIs, I booked it up to Work Suite, looked at the request and response. So this is a simple user information API. You pass in the username and it will give you the JSON of the information there. And the second one is simple authentication API, where you pass in a username and password, and it will get you whether it is authorized, whether it is the correct password or not. So some simple straightforward findings. On the first couple of minutes itself, I would see that there is, instead of a bad authorization or a simple authorization, there was a missing authorization there itself. There is no authorization. It is in the get user either API. So what I was intending to find out was whether I could use the authorization of some other user and figure out if I can access stuff of some other user, which I could do that because there was no authorization here. The second stuff that I found was the API was releasing some server information. I could figure out that it was an Express-based app, so that in the hands of attacker can be misused. The second stuff which I tried was to see if the app was vulnerable to SQLite, and a simple dash and current thing payload did not give me much, but it did export. It did not fail. It failed pretty seamlessly, so I figured out that this could be vulnerable. And I tried a couple of more things where I just passed in an OR operation, that simple OR payload, and I could get the details of the first user itself. I could find out my invalid path. I could find out my username. Now I wanted to see whether I could expose this to more information, and that the API was not intending to. So I knew a little about how the database was structured. So I did a simple union select query, and I was able to expose the credentials of the user. So I knew that I could union with the user ID, and I could get the hash password. So it's essentially a hash. And since there's a gray box thing, I knew it was SHA-256 hash. So I was able to use John and able to crack the password. A pretty bad password at that. And secondly, this should have had an MSA which was bypassed in this case. So a lot of different findings on this very simple application that were not intended. And obviously I was able to authenticate with that and get a successful message for the So yeah, I should be scared. This was my app, but I did get a sense of exhilaration that okay, I was able to get somewhere with this. So yeah, next app is a simple authentication app where I upload the SAML 2.0 XML metadata and verify whether it is valid or not. Now, this is a very single one-pager application that was there written in PHP. So all it really does is it basically upload an XML file that shows you whether it is a valid, it follows SAML 2.0 request response standard or not. It's a metadata standard. And what I was able to find through a simple manual testing with different payloads was that it supported path traverse. So I just simple traverser of the path to that parameter. I was able to tap out all the permission sets of the server where this application was hosted. And the next thing was JWT test application where after authentication, it issued you a JSON web token, which can then be used to communicate to different APIs as part of an authorization server. So, how I did, what all I did here was I just tinkered around with different parameters using Bubble Suite, and I figured out that you could just change the redirect URI. So basically what it did was it received a request in the get parameter of a client ID which was pre-configured and pre-decided, and a redirect UI where you have to basically post that JSON web token. So what I could find was that you could change the parameter, the redirect URI, and post the JSON web token somewhere else. And that can be then used to basically log in into other applications where you may or may not have access to. And yeah, this is that. So if you see here, the payload has the subject and all, but I am passing over the token to jwt.io, and where I could basically read the token. So yeah. So those set of the journey with my set of applications showed me a few 5 different vulnerabilities I would find. SQLite, Open Redirect, some hard-coded secret segment, and that was the scary part. Was I satisfied with that? Nope, definitely not. I was a bit shook up that something was broken. A lot of the apps were broken. I needed to do something about it. So, like I said earlier, I love breaking stuff, and I have broken my own applications. So time was to build it back up and fix all my code, fix all the processes associated with developing and deploying the code, which is what brings me to the core of my presentation, that is security by design. So that involves writing a journey of the code and application, right from writing code till deployment, and having multiple checks and balances between each journey of that particular piece of code, so that at any point in time you try to determine whether there is some vulnerability that is going forward with the code. So we move on to the first step, that is writing secure code. So a few things that I realized after going back and reading the code that was written after I broke those apps was that there were always some warnings issued by the IDE where we were writing the code, listing out that, okay, this code might have some problems associated to it. Right, it even ended up pointing out some basic where you can fix that. And a few glaring mistakes that should definitely be avoidable, something that we should definitely be looking at and missing it out. So, with the Node app, if we reiterate back to the code, we could see that SonarLint, which I used as part of my code, it was pointing out that, okay, you are going to have this app leaking server information. Fear, that could have been caught right here. SQLite is even pointing out that you have potential SQLite in here and should be using proper input sanitization. It's pointing it out right there. And yeah, we obviously tend to miss out on all the stuff happens. And this Java app, which is for the JSON Web Token one, it had a secret. It had a SHA 256 secret right there that was responsible for signing of the JWT, and it was hard coded right there. So in case of any lapse in judgment or any leak of the secret, could easily backtrack creation of that JSON web token. And there's no simple way of renewing that token, renewing that certificate. And obviously, this was the second thing associated with this app. Even though we were configuring where we need to send the token to, if you see the highlighted sections right there, you could basically change the parameter of the redirect URL and you essentially sent it to the one that was received in the request rather than what you already have there. So that was support problem of that. A few good practices that we should all be looking at as programmers. Do not ignore IDE warnings. They definitely point out some hotspots that will gather, and those can be potentially exploited. Simple input sanitization actually is the most basic stuff that is any programmer should know. Validate your input. I cannot emphasize that enough. Do not eat exceptions and warnings. They definitely help in navigating through the endless plethora of logs that you see when you're navigating to figure out if there are potential problems. HTTP responses, it always helps in throwing back to the client that, okay, there is a back request associated to it. Do not ignore this request. And log appropriately, you should always be able to figure out what is happening there. All this definitely should all be heeded too. ID warnings, like we said, can be cone smells, or they may even be potential libraries or a very simple potential secret hotspots like that SQLite or Server Express version that was being pointed out. So yeah, do not ignore the warnings. Vulnerable library. So if we have a look at this Java-based application, SonarLint is basically pointing out that, okay, these are the vulnerabilities associated with those dependencies that I'm using as part of my application. And if you go, I can checkmarks is the one that SonarLint uses here. It even gives you, okay, how it can be exploited. And it's not super hard to find out ready-made exploits for those vulnerabilities and CVEs that are pointed out here. So it gives you a way for you to use a fixed version of those libraries, so your app is not vulnerable to those vulnerabilities. So it is good again. Sanitize input, those are very small things, small things that you can do to fix your application. So if you see here, simple SQL query right there with strings can be replaced by a parameterized query. So if you see here, I replaced that with a parameter and now my app is not vulnerable and I will not be able to exploit the SQLi with this. So very simple one-liner change and my app is a little more secure than it was. Simple PHP application with the box traversal thing. Simple getting that file path and replacing that with a baseline path which you cannot traverse. Case with simple tips for that solution. And second step, now that you have written your code as per and not ignored those warnings, the next step is decent code reviews. I cannot really emphasize that enough, how much of a good code review is. Not everything can be automated. Even like I know there are good code reviews happening to Copilot and all, but I mean, a human will definitely know somewhat better about how your code can be vulnerable. And a simple multi-layer code review process will allow in ensuring that your code that reaches production is of a better quality and better security than some code that is not properly reviewed. These code commits can be easily point to the developer that, okay, I need to fix my code. This cannot go into production. Simple process. Third step, now that my code in my branches is or have been reviewed, I need to make sure that there are no vulnerabilities associated with that we're not breaking or reintroducing more vulnerabilities. So what we can do is introduce a little more pipelining, a little more automated testing through different layers we can do. And then post deployment, we can do a few more automated tests around it and see how we can do it better. So how we do it is we can use a different set of tools for Jenkins, SonarQube and all. So to see on this, SonarQube is basically pointing out the same stuff that we have pointed that we found at Sonar as well, that were pointed out during code reviews. So I purposely put in this same thing. You can obviously, once it is going into production, it should not be prompting for any potential vulnerabilities because they would have been addressed per year. But just in case there is anything that is missed, SonarQube or any other tool will definitely report it. Okay. And you can then ensure by putting in different set of quality gauge that, okay, I should not be reintroducing a vulnerability that was pointing out before, or at least I should not have some timing security hotspots or critical vulnerabilities associated with my code. All of this comes under SAST and DAST, I guess. So, and the developer should be notified that, okay, my quality gates are failing, so I should not be pushing this code out to staging or pre-prod environments. All of this reporting should be pretty transparent about it. Right. So once we do back, we can do a set of post-deployment checks. So post-deployment checks, what we can do is put it on staging or pre-prod environments and run some automated scans to figure out, okay, my stuff is still not breaking. So what I have done here with my APIs is that I have written my own custom scripts to figure out whether it is vulnerable to SQLite and run that through Jenkins or SonarQube, whichever appliance would use for my deployment. And this can be done manually for a Kalibara pipeline. And for my web app, I have written some automated tests using Cypress here. You can use Selenium or any other automation test that you use to write on. And this show that my app is not vulnerable to outrunners, right? So I have deployed my app here to T-Card and everything works. So what we have basically done, if we head back to that flow, we have done security testing on by writing code and being pretty mindful of the code that we are writing. We have been mindful of pre-merge checks on as part of our repositories, code repositories. We have been putting in more security checks as part of our deployment process. And now we have deployed stuff on, really we tested it on our staging and pre-prod environments. And now we have deployed in our production environment. Is that the end of it? Okay. We still have to do internal security tests and external security tests. So internal security tests, obviously you can have your organization have a pen testing team so that they can run their own versions of tests and give you a report, something that you have definitely, you may have missed actually, and make sure that, okay, this code that's going to be used by customers has been very tested, and some of to people using your app or applications may be requiring it for compliance purposes. So that is unbiased. Externality tests give you a more unbiased view of your security tests, so that any tests that or any schemes that have been missed by your internal teams should not still cause any balance break in their application. So it's a good idea to have that internal and external tests consistently over a period of time, so that your application continues to remain more secure. Right? So, like I said, we got writing more secure code through Litic, more security in our test processes through better code reviews, pipelines having multiple automated tests that are happening, manual and automated tests in staging and pre-prod, automated tests in staging and pre-prod environments, as well as external tests, external and internal tests in production environments. In a piece, to an extent, because your application will never be completely secure, it will be secure to an extent. There are obviously chances of your application of some other new vulnerability that is being detected. All of this needs to be a continuous process, and it keeps on going. How like never stops. Alice. So, what are some key takeaways? Learned a bit about how to hack on a little of real life applications rather than just those applications that you use to hack on. Then different stuff that you look at while writing code, some very basic points that are often missed on writing code. Introducing some good operational processes to make sure that whatever code goes out to production is battle tested, and multiple checks and balances to prevent any sort of failure. So yeah, those were all of at my end. I'm happy to take any questions at this point.
It would have the code to decrypt it as well.
It's never decrypted. It's always compared in hash format.
You don't put in the source code at all. So what you typically do, you rely on some Monday to be the story. So if you have a key vault, you put it in there at runtime, inject it into the context. So whether it be environment variables or some other mechanism that typically environment variables. So if you're using something on the cloud, typically they have some sort of secret storage, whether it be a FreeBSD or outside, store it there and then inject it at runtime. So it's only available in the memory of the application. Yes.
So store the credentials somewhere else.
Yeah, because let's say you get an encryptor, where are you going to put the key? Oh, so where do I hide the key in my source code? So you should never put anything in your source code if it matters. You should always inject it at runtime in a system that is separate, like a key vault or a secret store. And most cloud providers or some internal systems.
So what is abstraction is what he's referring to. Abstraction of your DNS and the credentials.
Something like that. But what you want to do is most likely to take advantage of either some library mechanism to get in there at runtime, or environment variables, a very obvious one. And how does it get there? Well, maybe it comes there from launching a terminal to inject it there, or maybe it comes in from the runtime system. So you 100% can't put in your source code, obscure it, try to encrypt it, because encryption is a two-way thing. They have to decrypt it with the key.
Yeah, exactly.
So it's the same problem. So yeah, don't put any source code. Don't obscure it. Don't do anything like that.
Thank you.
So you found by doing happy on your own application is the exposures. What would you say easiest way for programmers from yesteryear to catch up with doing the hacking and new programmers coming out and understanding being both the developer and the hacker security? Because you stop at CI/CD, you stop it in point.
So your question is basically that what's the best way to
Yeah, happy to change the that's what I'm looking for. How could we change the trading and the message and get people to understand code exposure is bad? How do you shift the mindset?
So, I guess the best way that I find is that use some compromised VMs that are there available on WhatsApp and a lot of those platforms that I mentioned earlier. So they give you somewhat of a compromised applications, and you can use those to find those vulnerabilities associated with that application. Try your own exploits, right? Read upon a lot of these exploits, try them, use Metasploit or whatever tool that fix your fancy, and see what all you can get out of it. And it's more towards, you know, that this application may be vulnerable. How can I best exploit it? I mean, I guess OneHub is probably the best because it's targeted DMs as well. So that, okay, let's say there's a DM that gives you is super vulnerable to SQLite, and you can spend hours trying to figure out what different payloads that you can give and try to get more information, expose stuff, change stuff, break all the authorization schemes and that. So it's a very good platform to learn. Yeah,
that Ross, just for me, just to add to the previous question, said your company had body for exits or things like that. You prepare so platforms sets and secret code warrior and a lot. They're both and Asian leaderboards. I was it's some vulnerabilities, but they make it so that fixing more practical. They do give you on the sheets to break down.
Yeah, exactly. It's not super practical, but again, if you're a developer coming from that perspective, it's best to try stuff on your own. You may spend hours trying to figure out that, okay, my application should not be vulnerable, and you may come up with nothing, which is may be a good thing, but for learning perspective, I guess the OneHub and Gosaraka is the defense.
Yep, so more on that fact that platform, it also gives you uniforms and you can have in competitions as well. Yeah, that's kind of like shifting the mindsets of people. Yeah,
but because it's also shifting to if you're competition internally.
CBX and all is what you talk about, right? CBX, yeah. CBX are very good way to do that.
Competitions internally to ensure how the developers are and their own other colleagues to get through. So easy to
it's good. All right. Yes.
I do have a question actually. So, did you just find out about these problems like 2 years ago, or you said I said you get a software developer personally?
Yeah, no, I started reading up a little about hacking over the past 2 years, and yeah, around that time that's when I stopped. And the phases are the better.
Yeah, because the part I find, but it's arguably troubling from my perspective being a software engineer, is that if you think about the list of all the common things that happen all the time, if you're not thinking about security, you'd probably say SQL injection will be the first thing that comes to mind.
Yeah.
It's the most obvious one. Don't put keys in source code, especially when the checked interface has a deep in the source code.
Yeah.
So it's not really an attack on you to say. It's just more of an extrapolation. If you want to answer the question about why is Conf so popular, why I'm talking about the same things, there's an obvious disconnect between these obvious oversponsed top 10 follows, and they keep happening. Someone has experienced this out, and we found out a few years ago that, you can do SQL injection, and maybe the user will try to reverse it directly, or they're in the problems. You don't need a vuln tool to tell you that, so it's just curious. It's more of not such a question. It's more of a state of. Does anyone find this troubling? That someone who's a principal engineer, 20 years of experience, like where the average skill level of where our software engineers are, why in 2024, why are they still having SQL injection?
Exactly.
Hey, don't worry about your SQL code warrior, those tools. That's for the cool stuff. The basic stuff. Why are we joining user into it and stuff? Or why are we at JWT? Why isn't that encrypted for money? Why aren't you using the encrypted version? Or why aren't you use the signing version? Why redirect it to somewhere else? Why not just return it to the place that's asking for it? And why are these mistakes all happening? Well, that's really what my comments about.
I mean, that's the state of development at this point in time, which is, I mean, that's the whole point of the session, that you may think that you're writing all that code properly, but I mean, there's an obvious disconnect, and it's the simple stuff that breaks a lot of stuff. Like simple stuff such as SQLi, which is causing so much damage across the world, and that's pretty revealing at times.
Yeah, I think I had a comment on that as well. I mean, perhaps might some other result that come up. Projects and contracted, they get told that and they go. So they're up there, so kind of like common learns from your farm and you trip down the park. But on track, but you think about the park like very shortly. Your time and you go to Quattro and all the finite cycle on this one left on that. You just get that falls on that security fund thing, you know? And I think maybe that plays a part in coming. I could definitely appreciate that from the diligence perspective, like not writing maintainable code, depending on a whole bunch of BPM packages and much shooting up a day. That makes sense. It requires diligence and you have to be testing the game for the names or software care about those things. But at the very beginning, the time difference between used prepared statement and joining things together, there's no difference. And it's no. And so to make the excuse that, it's just a contractor and they don't have their future care, and that's BS. Like, it's...
Yeah. I might add to that. I think this goes back to building awareness. And you know, we educate a lot to our stakeholders, the business, about security, vulnerability, cyber awareness and all of that. But we internally, we don't actually invest enough in our own programmers and our own people in IT to actually teach them about the vulnerabilities within this. And being in IT, you know, a lot of us, we're quite introverted, not extroverted. We keep to ourselves quite a bit. We don't leverage a lot. We don't. So I think there's that whole element there's a bit of a gap there about just building that awareness across IT. And, you know, one of the biggest vulnerabilities within with security is our IT people themselves. Like, you know, password changes, we forget to change passwords or things like that. So I think there's that kind of element that we need to take into consideration and build awareness within our IT departments as well, with our programmers. And that could be just something that because we're so used to doing things, we forget that whole element because we're too busy focusing on the business. We're getting to look internally.
Well, definitely every business has the same goals. And there's a reason why your enterprise apps, like your internal apps that you're probably using for some asset management, everyone hates their internal apps. Why? Because they're so targeted to a non-profitable market. And so what happens is that ICP functions in businesses are always just, you see it as just a capital expense. They don't generate revenue. So even the best tech companies, well, even your Microsofts and your Metas and your Googles, they're still facing products have the best stuff. And even that, I'm pretty sure they have some crafty old, unmaintained 7-year-old plus crap that no one cares about. But my argument is more about the development side of things. Why is there a disconnect between knowledge that almost any person that's in this conference knows about because it's in the top 10 of the things that happen, and why is it still happening in code with your developers now? Is it because people don't get along, or is it something wrong with education systems or something else? Misconfiguration with systems is a different story.
One thing that I can definitely point out is one thing about knowing what can happen, and one thing is actually seeing it happen. So I guess people may have that in the back of their head, but they're not aware of the proper impact of it. They haven't ever seen it live until it effectively hits them in the face in production. So that is probably one aspect to it.
And yeah, another aspect would be governance, ICT governance. Maybe we're not doing enough in that area.
No, job is an important thing. Well, what is happy, you have a disconnect between, because what happens, you have the gatekeepers and the people doing work, and the people doing work, they have timelines and pressures. So they do have requirements that have to satisfy functional, non-functional. For some reason, what's happening in the non-functional requirements or functional is the security aspects of it. Because if you think about it, vulnerabilities are just bugs that have security manifestation. But they're just bugs. No software developer goes, oh yeah, because governance is my... No one wants to create bugs. There's a problem about understanding the basics. So this is not so sophisticated security happy stuff. This is security research. Some top tier person that found how to do something new. This is written by everybody. 101, what not to do in 2024. And the fact is that this is a tool. And the fact is, there's some questions also. Where do I put our private keys? That just blows my mind. like, it blows my mind that, people who are probably not even the worst of us are asking those questions. What's happened to either educational system, or why is there a disconnect between the people that know stuff, or the people at this conference, and the people that attend the dev conferences? What's missing? This has been no more acutely aware to me than what going this talk and see your reaction is. And also next to Compass, I have a really solid engineering here with Batforge. But it's just an eye-opener to me. But in my opinion, a lot of our problems are caused from some grassroots problems in education of people and in the mentality, the disconnect between security, the fact that they're gatekeepers to people's behavior. Because a lot happens, like, for example, let's say you're using Red Hat Enterprise Identity Security System, right? In an ideal world, you got firewalls on everything. Everything is a fail secure. You use systems for everything. All the policies are turned up to 100. And a security person says, that's what you have to do. But then someone's trying to write some code, and they're trying to, say, modify something in the root file system. They can't figure out how to do sysplitting. So what ends up happening is that they can't figure that out. Security says you must do this. And then it gets escalated up to business, and they go, well, it turns out we're not doing any security stuff now. And that's what happens. It's either really locked down and nothing works, or it's not locked down at all, at least the software works. But then we have people go, oh my God, I figured out how to hack my software. Is it not hacking? This is just the due village to hack an egg startup development. And that's what is, it's really troubling, to me, that this is a thing now.
It's still a thing now.
It's still, and that is the
William item.
I feel ashamed for the software development people if this is how it is.
Very healthy conversation. So it's really good that you're raising these awareness questions, and but we're all a part of it. So yeah, it's there is a disconnect.
Yep, I feel it. Particularly the idea is right. It's
legacy systems, and you can feel the panic in the breeze. So thank you, Gaurav. If you have any more questions for Gaurav, please, or back from Lee Heki down in the room. So thank you very much.